Terrance Evans, welcome to the show.
Thank you for having me, Chad. I'm excited to be here.
Yeah, I'm excited to talk to you, especially considering your focus on software, but we're going to get into that. Um, usually a good context to start these discussions is to understand a little bit about what are you doing now, where are you at, what are your responsibilities, and after that, I'd love to hear about the career journey, like how'd you get where you are today. So let's jump into that.
Oh yeah. Currently, right now, I am a digital engineering systems engineer. What that entails is a combination of designing, developing, and delivering like integrated digital thread and like software tool solutions for the actual engineers. It's a combination of designing like cloud infrastructure to support those needs, a little bit of Azure, Kubernetes, but also a little bit of just like integrating like run of the mill like engineering tools like models, system to systems architect, Siemens
Huh.
PLM, those types of integration tools. So it the tech stack varies, but I do quite a bit
Yeah.
of that.
All right. Awesome. Good deal. Oh, I'm super excited about this conversation. There's been so many discussions about like what the IT stack looks like, especially in the age of AI and AI built integrations, but I'm going to hold off. Um, talk to me about like what's your career journey been to this point? Like how did you get into this like lane? Talk to me about
Man,
that.
very interestingly, I would like to say I kind of stumbled into an opportunity at Boeing. An opportunity came up. I jumped on it, and where I started, I was really like on the intersection of like hardware and software integration, like right before the physical like test assets or like the simulators would go to the lab. And
Hmm.
so I really, really enjoyed that. But like the biggest glaring things about that process was like tons of manual processes and a lot of single point failures.
Yeah.
And I kind of stumbled across a mentor at that time, and he told me, he says, "You want to know something? Uh, no one ever is going to be upset about you being able to automate your own job." And so I said,
Huh.
"Okay, well," I kind of took that as a challenge, and I started to automate pieces of my job little by little. And then it kind of evolved into an opportunity where I would actually join a team that was building and integrating digital thread solutions across like your classic engineering tool suites like Magic System Architect and like the PLM Team
Yeah.
Center suite. So it's
Sure.
evolved from there, and I kind of I felt a bit more confident and kind of grew from that and started integrating and designing more integrated solutions using different things like Palantir, helping like engineering management solve and answer some of those questions while also still
Wow.
supporting the engineers at like their base level of what do they need to do their day-to-day job and how can I provide solutions for them that makes their job easier and they can focus more on more complex tasks.
Wow. Oh, that's so cool. Uh, how did I mean, was this always kind of like a vision? Like you talked about kind of stumbling into opportunities, but like, did you have an idea? Did you want to do like IT solutions and stitching stuff together in engineering? Like, talk to me about that.
That like I really kind of like you said, like I kind of stumbled into it. I fresh out of college, I got a job in IT. Started as like a support desk coordinator, kind of like IT support with like application support, and then within
Mhm.
45 days of that, I got promoted to like an integration analyst. And so like from there, I realized I just had the appetite to learn and integrate solutions and figure out how things work, and I
Yeah.
kind of took that like native IT background because that's what I studied, and I kind of jumped into the world of engineering, and I did took a little bit while to like learn a few things on the engineering side of the house, but when things started to meld together, that's when I realized like, oh my goodness, I see this vision of how to pull these solutions together, how it's this relationship that like that ties almost like the both ends of these engineering V, but in a completely different context.
Yeah. Oh, wow. All right, cool. Good, good, good. Um, all right, so let's talk a little bit about change agents. We talk a lot about change agents on this podcast. And we always start with the same question. How do you define a change agent and what they do?
Ooh, that's a good question. I would say, excuse me, I define a change agent as someone who is a catalyst, but also solution driven.
Hmm.
Because too often times you have people that are catalysts to get things changing, but they don't necessarily have the push to see the change completely through. And I think a change agent has to be a catalyst to ignite the change, but has to care and feed the solution all the way through. Oftentimes, that I'm constantly reminded as a change agent, you have to remember you're going into other people, functionally other people's homes. You're
Hmm.
going into their home, and you don't necessarily walk into someone's home and say, we need to move this couch, repaint this wall, and make all these changes. You have to understand their environment. So I think being a change agent really embodies being a catalyst, but also understanding the people that you're working with truly, because you
Huh.
don't want to disrupt what they have going on. It's you want to deliver incremental solutions and value one piece at a time.
Mm-hmm. Yeah, makes a ton of sense. Um, Love to hear from you. What do you see as the critical like traits and characteristics of successful change agents? And you just touched on one aspect of it, I think, the people side of things. Maybe we can start there. I'd love to talk about process and technology as well, but can we start with people? I'd love to hear like if you were to construct the perfect change agent, like what would that look like from a people perspective?
I would say absolutely a person who's outgoing and someone who's patient. Because you're not sure exactly when you go, depending on how you were introduced to this person to kind of like come and mess up their house a little bit. You're not sure exactly what defenses they may have, like protecting their work, especially now with like the AI is like the hot buzzword. So you people are unsure.
Sure.
Are you going to automate me out of a job? Are you trying to
Yeah.
replace my job with AI? And so it's really just being patient and taking time to understand their job. I think that piece of it is so important. One of the biggest things that I do frequently is just take times if I'm working with the flight team. I want to sit with them and understand the day in the life of their process. I want to understand what are they doing, what are the daily habits that they have, what tools are they using, what are the process bottlenecks, what aspects of the job do they enjoy, and it truly
Yeah.
lets the wall down to truly help you understand them, and they're more respect of accepting of change, and they understand like, okay, this person isn't here to completely disrupt my world. They want to understand where I'm coming from and how that input can help drive a solution that makes my life a little bit easier and help me enjoy my work a little bit more. So I think
Yeah.
patience and understanding is huge. Because at the end of the day, the technical, like technology is constantly changing. The technical solution piece of it, there's a lot of foundational pieces that you integrate with, like different things like APIs, databases, baseline infrastructure like compute. A lot of that stuff doesn't fundamentally change. There's certain ways that you can integrate tools, but truly
Hmm.
understanding the people in those teams make the
Yeah.
world a difference.
Wow. That's great. That's great. Okay, so follow-up question before we move on to processing technology. Um, where and how do you pick up those skills? I mean, some people, you talked about like a personality profile maybe of being an outgoing person, but along the way, were there any formal like places where you could pick up those skills, or was it just like you had the right mentors? So like, talk to me about that.
I think it was part of like partially the right mentors, but my background is very diverse, even prior to like jumping in the career field and different things like that. So I was able to pick up some of the outgoing skills during my time in college. I was a wedding DJ and videographer, so being able to talk to people on the spot and try to like get them to open up with something I built. But I think from a more like structured path, I would say just talk to more people as a whole. Just it's the
Yeah.
from my perspective, it's the curiosity to understand something that is not natural to you. And once you enter people's spaces, and they recognize when you're genuinely curious versus when you're trying to just push things on them. And the
Yeah.
curiosity opens up people's mind, because at the end of the day, I'm working with engineers that are passionate about their domains, and giving them opportunity to communicate and talk about their domain in ways that they're passionate about, that, like,
Mm.
that's up their alley. They want to dive deep into the nuances of why they enjoy their work and what they do. So the curiosity is the biggest piece. Remaining curious, and also building, like, slowly building the outgoing skills. And even if it's starting within your own team, starting with, okay,
Yeah.
well, what does you do on the team, and how does it fit into the larger ecosystem, and like starting, like it's like starting at home, kind of like understanding
Huh.
with your own team how things transition to the life cycle of your team, whichever side of the V you're on, understanding how they work, how they operate, how they integrate, and you start to understand your team a little bit better. Then you start to understand how the entire product fully is engineered, and you start to go piece by piece. And that's honestly my best suggestion: remaining curious, and building the skills of just talking to people, which is something that we oftentimes don't do as engineers. We get in our silos, but curiosity and always talking is helpful.
Yeah, no, that's great. That's great advice. Um, and you actually segued in the next section really, really well. You talked about the engineering V. You talked about, I mean, people's responsibilities are often tied to the piece of the process that they participate in the most or that they own. But engineering can have very complex processes, practices, and methodologies. Like, talk to me about that as like a skill or set of traits that a change agent needs to have.
Oh yes, it's the adaptability, being able to adjust and understand, like, the full aspect of the engineering V, both sides of it. And I think that's what's, like, very pivotal in, like, digital engineering. You have to understand the full systems engineering V, because
Yeah,
you're building processes and solutions on every step of the way, from requirements definition to scope definition, all the way to the actual manufacturing of the product. And
yeah,
so being able to understand at least some base level understanding of those things, that really help you architect the processes. And, like, um, you're really just understanding how can you build this digital thread too, that then develops into a functional digital twin that's actually useful for what you're
mm,
trying to do. And so
yeah,
being able to understand the full V, the tools they use, the processes, are so, so important. I think a big thing for myself is, um, something I learned very kind of early when I really stepped into this digital engineering world, is truly understanding how impactful PLM is, especially like Siemens Team Center, and seeing
yeah,
how things on the design side of the house directly impact things on the manufacturing side of the house, and how those
yeah,
change requests flow through the system, and how they drive change and non-conformances. All of those, like, nuances about the tool itself made me realize and understand, okay, these are the things that, like, this is the information they care about downstream, these are things they care
yeah,
about upstream. How can we find a way to get them to meet in the middle, so we can make a more cohesive process? And so when you're passing this aircraft off to a maintainer, they understand the design thought, the manufacturing thought, versus having a segmented thought, and they can see, okay, I see how this product made it fully through the V, and I understand what changes are made, why the changes are made. All of those
yeah,
things paint a cohesive picture to understand the product you're engineering much better.
yeah. No, that's great. That's great. And you you did another great segue there with technology. And actually, it's really interesting. We've seen that, say 30 years ago, you could run a process on email and documents, and they could be kind of separable, right? You could split it out. But today, the technology and process are so intertwined, you can't detangle them, and maybe they shouldn't be detangled. But can you talk a little bit about how closely connected technology and process is today?
Oh my goodness, technology and process are hand in hand, especially from the perspective of when you don't want to lose anything with process and technology.
Mm.
Oftentimes your technology is almost like your note taker of your process. We
Yeah.
use different tools like Jira. Jira is also
Hmm.
very common tool engineers use, and it has a detailed workflow process. And each step of the workflow, there's an artifact that shows it was changed by this person at this state. And as you work through the
Yeah.
process, it shows you what happened at that date and time, who made the change, and even if there's like updates to the description or comments, they tell you exactly what it was and when it happens. And I think technology truly makes process more accessible.
Yeah.
Um, it truly creates a auditable process, and um, it really kind of pulls together exactly what we're trying to do. It gives us it creates an audible record
Yeah.
of everything that flows through. And so with that, we have an environment where these things are so tightly coupled, and granted, each tool handles process and technology very, very differently. And it's more so like your process is driven by the technology that you use. Like with Siemens Team Center, the different workflow states of like a change notice, what level of signatures you need, versus a
Hmm.
drawing release. Those are processes integrated within workflows, but they all contain auditable records that could be used later on in the life cycle of the product.
Yeah. No, that's great. That's great. Um, and then yeah, let's shift gears. I've been dying to get to this topic to talk about like AI and the traditional IT ecosystem, right? So if you look at engineering, you got CAD, PLM, the CAE simulation tools. There have been I, I've been involved in a lot of discussions recently about how AI can be can play two roles in that ecosystem. One is acting as a dynamic integration builder between tools, where traditionally those integrations have been very, very fragile, could break very easily, that kind of thing. But the other is to be a layer that allows users to interface down to those IT systems, right? So AI can be the natural language interface to those things. Talk to me a little bit about you're a lot closer to this than I am. I'd love to hear like what's happening in practice. Obviously, you can't share exactly what's going on in your employer, but like in general, what are you seeing? What's the potential there and what's the reality?
I'm seeing it in a lot of the different ways that you mentioned. From is it like it's the natural language processor that bridges the gap between traditional engineering and IT. I'm also seeing it as the almost like the underlying helping like driving decision to drive like different business insights.
Mm,
Where like I've seen instances where you give the agent access to the data and you let it extrapolate whatever's there. And then
yeah.
you start to drive into it's like, oh my goodness, I didn't even think these two different data points correlated, and it allows to make engineering decisions a little bit better, like program management decisions a little bit better. I've seen it in those fronts for sure, especially on the latter point,
Mm,
because I've seen how a lot of times because engineering programs are very structured with what staffing they're allowed, and so it oftentimes bridges that gap if they can't bring on a uh, full IT team of engineers or like a full like digital engineer scope. They
yeah.
tend to rely on like some of the agents and different things to help bridge that gap. And I also think um, in my experience, especially at my employer, it's a lot of times it's used as an educator almost. It's like
Huh.
I'm not very sure about this area. How can I help bridge my skill gap to meet my actual need? And
Yeah.
that's actually I feel like it's most useful because it's helped bringing the employee up in skill and helping teach them the things that they need to know, and it also
Mm.
acts as almost like, I won't say a mentor, but like a guide to help them execute the solution that they're looking for. So I've seen it in a
Yeah.
variety of ways. Industry is moving very, very, very quickly
All
with
right.
AI
Yeah.
and agents and the different things like that. So I think it becomes an organization by organization basis. And I say that because we've seen stories already of how organizations are very, very quick to adapt AI, but they are not seeing the actual ROI yet. And the actual
Yeah.
infrastructure there, it takes time. And I think um,
Huh.
just being able to understand how AI could be value in your organization, and what are the use cases that you want to use it for are so, so, so important, because you don't want to get down to a rabbit hole where you're multiple millions in the hole of building the infrastructure, but you have no boundaries and no guidelines from
Yeah.
how you what value you want to extrapolate from it and how you want to use it. You kind of think of it as like taking the time to really do your research and understand what you want to use it for. They're almost like the
Mm-hmm.
guardrails on the highway. Taking the time to do that, they're there to protect you rather than like hinder your usage. And
Yeah.
everyone with access to AI agents being running almost rampant right now, with everyone using them on their phones, their computers, you have to very much put the boundaries in place and guardrails of these are the use cases you can use them for at work.
Yeah.
Can we integrate these guardrails into getting the agent to not even respond to certain types of questions? All of those
Yeah.
things are important, because then you're like, especially if you're deploying this agent in like a classified area or a closed space, or if you're deploying this agent
Mm.
that has access to the internet, and you don't want your data to be integrated to the end, like for model training.
Yeah.
That's where like the decision where stateful models, where they're learning constantly from the things that you put it, versus stateless, where it's trained on a
Mm-hmm.
data set back up to a certain date, and it generates responses based upon that data set, but it does not learn context from you. And I think those
Yeah.
pieces are very, very important, because it then drives, there's use cases where stateless models are better than stateful. And I think in
Interesting. Huh.
the defense use case, stateless models are great because it provides the agent with a quick response and can answer a lot of your questions, but it gives you the protections around your proprietary data and classified data, where you're
Yeah.
not exposing it possibly to the internet, and the agent doesn't fully know everything. They just say, this question was asked and I answered it.
Yeah. No, that's yeah. It makes me think about controlling scope creep,
Yes.
um, and really crucial because uh, yeah, I mean, you could go down a rabbit hole and invest all sorts of time and mind share into AI and not come out with anything. I mean, you could certainly learn a lot, but um, actually affecting outcomes, it may not do that. Um, let's talk a little bit about let's shift gears again. Let's talk a little bit about like the IT ecosystem because you mentioned Jira, which I find very interesting. I've heard like Jira and other Atlassian products, ALM being like a second tent pole. I hear more and more supporting the software development side of things, PLM supporting the hardware development side of things. And it just makes me think about the ever expanding footprint of the IT ecosystem used to support design and development. Like, what have you observed since you kind of entered this field? Like, is the footprint still growing? And what is the rate at which it is growing? I'd love to get your perspective on that.
Oh, absolutely. I think Jira is rapidly growing into the traditional engineering space. It the best way to describe this, and I think this is like, it's great personally. It provides the actual logical work linkages and dependencies that systems engineering fails to grab with the dependency of the actual work that needs to be done.
Oh,
Say, for
interesting.
example,
Huh.
you're a hardware team, Chad, and I'm a software team. And your hardware team is waiting for me to release my latest firmware version to integrate and test. Well,
Hmm.
the engineers on your team tasked with those integration tasks can link the issues that my team endure that have them delivering the actual software. They could say, okay, you say you go to your team, what is your help needed? And they say, well, I'm waiting on Terrance's team to finish the software version. They're currently in test, but once they complete it, I will then know I can transition to my task and I'm no longer blocked.
Yeah.
Providing those logical task dependencies and linkages, in my opinion, it, like I said, it captures the aspects of systems engineering and interdependency between teams that we don't traditionally capture. And that's why I think it's only growing in adoption, because
Mm.
you truly get to see how cross-functional and interlinked the tasks and segments of work are
Yeah.
when you contract the dependency of firmware development all the way to test and realize, okay, this is release. Now I get an
Yeah.
email notification saying I can start my task because my blocker is now closed and I can go and integrate.
Hmm. Cool. Yeah. That's, you guys are pretty mature on that front. I see a lot of organizations, they struggle a little bit with the following, which is, okay, software is kind of like the process is owned by an ALM or a Jira, something like that. Hardware is owned by PLM or something like that. And then you have systems definitions in MBSE. And sometimes the MBSE is at the top and it's driving down to the others. Sometimes PLM is at the top and it's driving down to the others. There hasn't been a clear hierarchy established as a standard in the industry. Um, how do you see it? Like, where are those three tent poles? Which one is driving which? Or how do they interact? Are they all peers?
I think they're all peers and they own kind of their section of it, and that's where I think digital engineering makes it like it creates the perfect ecosystem for them to live in, because
Huh.
naturally these are three different segmented softwares that don't integrate with each other. And so when you start to provide integration solutions between the three, you realize, oh, I can get my change notice that I just released in Team Center back into my MBSC tool, that I realize, okay, I have to update the architecture. What's changing? How, and what parameters am I being given? Oh,
Mhm.
I once I get the change request that comes through Team Center and Jira that shows, hey, I have work to do that's impacted. It provides this ecosystem of full understanding of whatever phase you are in that life cycle, of
Mm.
understanding what changes need to happen. How does that impact system engineers? Does that change the interfaces? Does that change my block definition diagrams? Does that change my internal block diagrams? And how is someone waiting for my work downstream? Are they waiting for me to complete my task? Or who do I need to wait for upstream, and different things like that? And so when you start to integrate those core pieces, you realize you're breaking down silos of communication, you're breaking down silos the way work could be done. And that's when you have people working across the aisle between hardware design and system definition, and in project planning and system definition. It creates
Mhm.
a opportunity to fully connect across the team. And that's when you start to realize your integrated product teams are not just systems engineers and hardware design engineers. It's a combination of project engineers who are planning the product, systems engineers who are helping drive that design, definition, and interface requirements, and the actual hardware engineers that are actually designing what you're building. And that's when you
Yeah.
almost start to get to the aspect of like scrum teams, like software, where you're integrated fully with each one in their own domain, and you can deliver incremental functionality piece by piece because everybody owns their area of the view.
Yeah. No, that's great. I'm hearing more and more about agile teams and scrum teams that are cross-functional across all those areas. And I think it's really fascinating, but also along with that, I'm seeing a lot of organizations adopting frequent prototypes, right? So they want to get to a prototype as fast as possible, flash software on it, see if it can get it to boot, the basics, and then progress from there. Are you seeing anything along those lines?
Oh yes, I am seeing a lot of times in I guess you said like in the defense and aerospace arena. The goal
Yeah.
is how fast can we get it to the lab to test and integrate it.
Mm,
Understanding how quickly can we get a similar hardware component that may not be 100%, but that's 75%. And how fast can
yeah.
we get a first release of the hardware to see, or the software to see how close we are. And I
Yeah.
think we're getting to a point where we are very much integrating almost like daily with based upon the software release cycles, especially as software matures and you have like a very mature like continuous integration and continuous deployment pipeline
Yeah.
that makes the
Hmm.
latest software available to your labs almost instantaneously once it passes all of its tests, and you
Yeah.
realize okay, almost each new day they're solving bugs, creating new different like, and it creates that feedback loop a little bit quicker rather than waiting months to integrate, but you can do that a little bit faster now. So I think
Yeah.
I've always been the idea of that like software and IT drives the world forward, and like the faster we can integrate and get the other world to integrate and catch up, the faster we can move the world forward. I listened to a podcast years ago. It was IT Visionaries, and there was
Huh.
a CTO who mentioned he and in his entire organization, whether it's software or hardware, he preaches the aspect of prototypes over PowerPoints. Don't talk to me and pitch to me how this change could help save me. Tell me how you did it and give me an example of it.
Yeah. Yeah. That's great. And that's so interesting. Like when I look at, companies like Anduril,
Yes.
um, that's like their mode, right? They want to get hands on hardware and get it running as soon as possible. And I think that's where a lot of legacy primes are trying to get to so they can be more agile. So it's really good to hear, that kind of approach being adopted in places where you're at, like where you're at.
Hmm. Yeah,
Yeah.
we're really trying to understand the bottlenecks in the process and truly get there faster naturally. Software is going to iterate a lot faster than hardware.
Yeah.
But understanding, I think what like can drive a lot of that acceleration is commonality in hardware, getting a baseline. A lot of times you can, let's say for example, with like a 737 or like a 737 Max versus 737 Max 10 and 9. There's going to be
Hmm.
a lot of commonality there. So maybe you can take like an 80% solution from one of them and then you start to integrate from there. And so when you start to get commonality on engineering baseline like that, you know
Yeah.
what to expect downstream, and it's a lot easier to iterate on.
Yeah. No, that's a great example. Yeah, absolutely. Um, let's talk about systems engineering. I'm really interested. I know that there are big primes with very, very mature systems engineering practices and methodologies, right? They've been doing it, some of them for decades. And I'm interested to get your perspective on how much is that still changing? I mean, is it fairly static at this point? Like, hey, we know what we're doing with systems engineering. We don't need to evolve and mature that much anymore. And if it is, it's very small. Or in other organizations, I see big changes, like big leaps and changes in methodologies. Like, what are you seeing? Is the whole industry like changing fast, or is it different depending on where you're at?
I think it's so nuanced. It's different depending on where you're at, what company, and what your customer looks like. Some
Yeah.
customers are like very MBSE forward, where they want to. This is the architecture, and we will. There's no more documented requirements. We will build out this entire system using MBSE. And there's other
Yeah.
times where You have customers that will still use documented requirements, and for integration points, understanding how the system talks to other components of the system, they'll use MBSE. And it is
Hmm.
very customer driven. And I think uh, Boeing does a really, really great job of really trying to understand that customer and deliver to that customer that solutions. So to better answer the original question, I think um, as a prime like Boeing that I work for, a prime, they have a very, very strong system engineering foundation. And so
Hmm.
when you have a lot of like the senior technical leaders and technical lead engineers with that strong background, it creates a very self-fulfilling ecosystem where you bring on some of the younger engineers and they guide them to, okay, this is what this customer wants. But since they've already
Yeah.
been trained up in very like a solid education of very good system engineering practices, there's a place that they understand, okay, there's a baseline with system engineering, but there's also nuance to how to execute and get it done. So I've seen on
Right.
like
Huh.
programs where MBSC is absolutely everything. And I've also seen in programs where they slightly start to lean into it into segments of their design, but not fully integrated. So I've seen the full spectrum where there's no MBSC to fully MBSC. It very much depends on program and company.
Yeah. No, really interesting. We had a LinkedIn live session. We had three kind of systems engineering practitioners, and they all kind of agreed that like the degree to which you leverage MBSE and model everything really depends on the program. And I think that kind of speaks to you need to have a competency internally to figure out like, okay, on the continuum, how hard do you go towards MBSE? And that's not easy either. It requires a lot of
Correct.
experience to make decisions.
Yes, I think it's a very, very tough line to like find, because at times you want to use system engineering to get you to a level of maturity before you start building and manufacturing anything.
Mm,
But then there's also times where if you swing slightly too far, you start to over engineer your product.
yeah.
And when you start
Yeah.
to get the conflict of physical architecture versus logical architecture clashing within MBSE, which is what you do with a lot of times when you get to those lower levels, that tier four, tier five, and sometimes at tier three, you have to find the
Mm.
right blend. I've been on some programs where they go down to, some segments go down to level tier two, and that's good enough. But then I've been on other programs
Huh.
where segments go down to level five, and then they're even considering, is level six doable? Should we go and define this a bit more? And so I think it very much depends. I think a lot of
Wow.
it really depends on what you're actually trying to define and what you want to, what you're writing requirements for, but also, are you making the product that you're getting deriving requirements from, or are you sending these requirements to someone else to build that product? And I think
Yeah.
that has a lot to do in times with like what level of fidelity that you go to. Because if
Yeah.
I'm delivering something to my customer and I'm defining it that I build, that's I can understand that I meet their specifications while also define giving it enough detail that I need to manufacture. But if I have an understanding with my customer that they want a certain level of fidelity, but I also know that I don't necessarily have the capability of making this, I need to
Yeah.
be able to send this to someone else, these same requirements to a good level of detail, to be able to manufacture completely. And I think that piece of it also drives what level of fidelity, how do you derive that? How, like, what, like, can you become like a happy medium between what the customer wants and the level of fidelity needed that someone who's not in your organization can take those
Mm.
requirements and build exactly what you need?
Hmm. Gotcha. That's great. I mean, to have that kind of flexibility, but to have that kind of flexibility is great, but it takes work to get there,
Yes.
right? And you got to make sure that that work is worth it at the end of the day, because sometimes it's not. Um, let's talk a little bit about SysML 2.0.
Oh
Um,
man.
you know, I, I'm actually a fan that it's become a little bit more code centric as opposed to diagram centric. I think that's a good thing. And I think it's been very fortunate because of AI and the ability for AI to code as long
Yes.
as it understands the language. Um, and and I think can make a big difference in people's ability to use SysML 2.0. You know, there was always kind of a barrier there that you had to climb in terms of a learning curve. Talk to me about what you're seeing there. Like, is AI making a difference with SysML 2.0? Are you seeing lots of activity there? Just love to get your perspective.
I think AI is definitely going to speed up the adoption of SysML 2.0. I also think AI will be fundamental, and I think, and this is maybe a bit of a hot take, but also very, very early claim. I think AI will be pivotal in maturing SysML 2.0 to where we may get a 2.5 and a 3 probably within the next couple of years
Oh, wow.
because of the ability
Huh.
to adapt fast and iterate and understand the product at a very, very deep level. As someone who's
Yeah,
had to integrate with and write actual integrations and containerize integrations for Magic System to Systems Architect, I
sure.
can tell you it you have to take time to deeply learn SysML v1 and truly
Yeah,
understand what the relationships are and how to triage to those relationships to get the actual data and the values that you want. System LV2, like you said, is more developer centric and provides an easier platform to integrate with, to run APIs against. And so I think the more we get closer to what all native software looks like, the faster we can iterate upon it. I think systems engineering is getting, it's expanding and growing to the point where these system engineering models aren't just being used to design the product. The values and the different parametrics that are being done very early on in the design cycle are also being tested and validated when you get to the other side of the V right before you deliver product. And so you can
yeah,
also see, it allows you to help you see, okay, uh, on my parametric diagrams, I was looking at these values and see how they kind of articulated, and you start to like arrive to understand, okay, as we matured the system, these is how those parametrics got a bit more narrowed down. And like, as great
hmm,
as SysML tools are, you're not necessarily looking at it. You won't have to necessarily look at it through a SysML tool. This can be viewed through
yeah,
like a dashboard visualization. This can be
yeah,
viewed through like a web page, and
mhm,
understanding, really trying to, where you actually almost get the like the full visual of like your digital thread of your um, as your product matures, and like these, being able to extract the value from SysML v2 and integrate a lot easier puts you in the perfect place to deliver a actual digital twin that has the things that like SysML has almost like blocked out of, that you had to more manually do,
yeah,
but you create this automated digital thread that gives you a digital twin that can go back to design inception from where you are
yeah,
today.
yeah, yeah. You know, yeah, there's been a lot of discussions on LinkedIn about product memory and the whole idea, you know, taking the concept of an AI memory and maybe extending it to a fuller kind of representation of the product, but also a historical trail, which is a great concept to apply because a lot of that stuff is just lost, right?
Yes.
It's in meeting recordings and Word documents, but rarely makes it into a system of record like PLM. So I think there's great opportunity there. Um, let's let's go back to one of the things you mentioned very early about replacing some of what you're doing or automating what you're doing. Um, you know, today a lot of people are facing that kind of question when they look at AI and their job. Like, how much should I really automate what I'm doing here? Or do I automate myself out of a job? Um, What's been your perspective on that? Because it sounds like you're pretty aggressive on that front.
Oh, absolutely. I think especially when I say automate, I look at the perspective of being able to the mundane tasks that take a lot of time but that don't provide a lot of value. There's been
Mm.
times when I've had to parse Excel sheets for data that are 10 to 15,000 rows long. I
Yeah,
manually that would take me a ton of time, but if I could spend 2 to 3 hours developing a script that can parse the Excel file much faster than I could manually. And I think it's different tasks like that. And I have the perspective of let me automate the mundane so I
mm,
can mull on the larger and more complex problems that we have. Like
yeah,
understanding the team centered data model, how to integrate with it, how do we want to parse that out, how do we want to push that, like truly understanding what, like, how can I architect a solution that bridges this gap versus figuring
mm,
out, man, I got to spend time parsing an Excel sheet, doing these like mundane things that can be done by different things like Linux cron jobs or just like
sure.
Python or PowerShell scripts.
Yeah, yeah, that's great. That's great. Um, yeah, and you're probably getting things done faster than you ever could before, which is even though it might be a mundane task, it's adding value. It's accelerating, the process for sure. Um, yeah, I'd love to wrap up with a few questions around what are some green flags and red flags about, when you're asked to kind of lead a change. What are some signs that, hey, this is going to go right? Or like, hey, maybe this needs to be a little more well defined, or I need more direction from an executive. For people listening to the podcast or watching this on YouTube, like, what would you tell them?
I think one of the things I would say it's um, I would say it's more of a beige flag to understand. I can sense there's some defensiveness there is when there's
Yeah.
a consistent point of, hey, this is our problem and we're looking to you to build the solution. And
Mm.
I think on the
Hmm.
surface level, yes, that's exactly what I'm here to do. But I think sometimes people don't understand that I need to actually understand your job and your problem more. What is your relationship to the problem? Are you early on in the cycle of the problem? Are you downstream of the cycle of the problem? Is it a data
Yeah.
problem? Is it a tool problem? All understanding all those nuances helps me drive towards the solution that I can deliver for them. And I think people oftentimes, because of native defensiveness,
Mm.
they're like, well, this is what the problem is, and like you have to solve it. And while I do have the desire to solve it, I need a lot more interaction from them to understand their
Yeah.
problem and better so I can deliver them a right size solution. So I would say a red flag is naturally someone who doesn't reply to emails, avoidant, does not like want to have the actual
Yeah.
conversation. But I've been in situations where I've worked with engineers and I let them know, like, hey, I'm reaching out. I want to see how we could like make some tweaks to your process to make it a little easier. And they reply excited. It's like, I would love to meet and to detail you through everything that I do. And I think like open and honest and curiosity are like the keys to being a change agent, in my opinion. Being open about what you're trying to do, being honest that I'm not trying to take your job, I'm trying to better understand and and free up some of your time from mundane tasks and
Yeah.
eliminate your roadblocks. And once you
Yeah.
start to communicate that more effectively, you that's how you kind of change people over time, especially when you really harp on the aspect of, I'm trying to eliminate the things that stop you from working. It clicks from like, oh, you're actually going to help me. And I think that piece is
Yeah.
very important. And I would say that's about it in terms of like red flags and green flags, especially because it's the cycle from my perspective, the cycle is pretty consistent. I've dealt with people who are like absolutely defensive, who will not let you touch
Mm.
their spreadsheets. I've also dealt with people who are like, yes, please help me automate this. And I've dealt with people from the perspective where they know they want something, and they're very open and they honest, and they're leaning with me to kind of walk them through to one, like, rebuild their process and how could they integrate it more, which I
Yeah.
also think is cool because I feel like in that way they learn more about the tech stack and how this thing works from a digital engineering perspective, but then they also get more mature on the steps in the process that they didn't realize were inefficient. And I think
Mm.
those are my favorite situations because I feel like myself and the folks that I'm working with learn more on each side of the fence. And then they also realize, like, wow, I can take out these 4 steps to make my life a little bit easier. And that creates more time. It helps drive faster results and all different things. So I think
Hmm.
in this space, at least for myself, it's a consistent pendulum of restricted to change and doesn't want to change all the way to, excuse me, very adaptive and wanting to change.
Yeah. No, it's great. Excellent. Last question. Uh, if you could redesign anything in the world, what would it be, even if it's just a better mousetrap? I'll give you a few seconds to think about that real quick. Hey, again, for everybody listening or watching, this is what this podcast is all about. Talk to change agents like Terrance that's driving change and improvements in a lot of organizations. So tune in for future episodes to hear from other experts as well. What do you think, Terrance? What would you redesign?
I would say the highway system in the Midwest, um,
Okay. Yeah.
specifically the Midwest, because
Okay.
I've traveled the Midwest most of my life. I was born and raised in Chicago. I live in St. Louis, and I find it so frustrating at times with traffic bottlenecks, Chicago traffic, just
Yeah.
figuring out a way to better streamline traffic at those high peak times.
Yeah.
I've seen different, like, video solutions of how to do this, how you, like, expand highways at peak times and you collapse them down to non-peak times. But
Hmm.
figuring out understanding of, like, consistent traffic patterns outside of, like, rush hour, what do traffic patterns look like on the weekends, and
Yeah.
truly, and, like, just naturally from, like, my digital transformation kind of mindset, what are the core problems and bottlenecks and times that we would have to look at to, like, make changes, how to connect more highways, get folks off more back roads a little less.
Yeah. I hear you. That's a great idea. I love that. I love that. Actually, that's kind of a popular one. I think I've had two other folks bring that up as well. So you're not alone. Maybe I can connect you with all the other ones that want to do it as well. We can
Please
get a
do.
we we can get a movement, right,
Yes.
of how we can make it happen. So Terrence, thanks so much for your time today. Really great advice for other change agents. Thank you so much.
Thank you so much, Chad. I enjoyed being on the podcast. I enjoyed talking about all digital engineering and software whenever given the opportunity.